Hello students, welcome back. We completed section 1 where we discussed the antiderivatives and indefinite interval notation and the concept of interval constant and some antiderivative rules. The constant rule 1, constant rule 2, and then the addition rule and coefficient rule. As a matter of fact, this one works for subtraction as well. For multiplication or division, on the other hand, they do not work. You cannot separate multiplication or division. For addition or subtraction, yeah, you can do that. And then the antiderivative rule for power function, special case when we have log function, and finally exponential function. Remember all those? And a bunch of exercises associated to those. Now let's continue. Here's a reminder, by the way. Now let's consider these cases. A little bit more general case where we have a composite function of a limited degree. Ax plus b goes inside the power function, inside the reciprocal function, and inside the exponential function. In that case, we have 1 over a popping up. The reason, you have to undo the chain rule. Start from the right-hand side, for instance. Take the derivative of this exponential. It stays the same, but by chain rule, you have to multiply the derivative of the inside. That's a, and that collides with this 1 over a and disappears. And in the end, we get this integrand. So this 1 over a exists to undo the chain rule. Same here. Take the derivative from the right-hand side. What do you get? It's a log function, so we have 1 over ax plus b. But by chain rule, you have to multiply by a. This 1 over a this 1 over a is there to undo that multiplication by a. So multiplication by a and this 1 over a collide and they disappear, and we have this integrand. Same here. Take the derivative. K plus 1 comes out and collides with 1 over k plus 1 and they disappear. Subtract 1 from the power, so we get a k power. Good. But that's not all. You have to multiply the derivative of the inside, and that's a, and that collides with this 1 over a, highlighted in red, and that too disappears. So these are a little bit more generalized cases compared with these. If you put a equals to 1 here, then you're going to get those. So you can consider these as a little bit more generalized cases. Let's consider some problems associated to these, and here's some problems on power functions, and there's some problems on exponential functions. One at a time. Power functions first. How about this antiderivative? Okay, all right, let's go ahead and do that. Copy and paste it. And then you can start with the power form. So instead of this, you can rewrite it as 3x plus 1 to the 1/2 power. And then you can apply the power rule. Add 1 to the power, 3/2 to the power, and then divide. But that's not all. You have to undo the chain rule, this 3, so you need a fresh 1/3. And then you have plus c, and that'll complete the problem. You can simplify this into 2/9 if you want to, but I wouldn't bother. What did I do here in the answer key? Here I did simplify, but it's not really necessary. How about the next problem? 3 over 2x minus 7. You can rewrite it in a power form like this. 3 is coefficient, and 2x minus 7 to the negative first power. If you add 1 and get 0 power and divide, that's not going to work because you have 0 in denominator. It should be this one. So how do you work it out? 3 is coefficient, log of 2x minus 7. But that's not sufficient. You have to undo this chain rule, so you have to divide by 2, and that'll complete the problem. What did I do here in the answer key? Well, here I have 3 times 1/2 separated. I went to 3/2 directly. Basically the same computation. Now one more problem here. In this kind of problem, I see this kind of answer a lot, really a lot. Excuse me, wrong key. Okay. Log of this thing. Like that. I see this kind of thing a lot. Focus too much upon the denominator. But this is really, really long. Really, really wrong, excuse me. Sorry about my accent. I'm from South Korea, so I still have some accents there. Sorry. Really, really wrong. Do not focus too much upon the denominator. And as a matter of fact, it's going to be better to avoid it altogether. Change it into a power form, and if you have negative first power, then go ahead with log function. Otherwise, don't. So let's go ahead with power form. So if I convert it into a power form, what happens here? Well, this is 4x plus 5, no question about that. What power? Observation number 1 is coming from the denominator, so it should be negative power. And then we have third power, so 3, and the 7th radical, so divide by 7. Here we go. Negative 3 7th power. Why negative? Because this thing is coming from the denominator. Why third power? Because this is third power. Why denominator 7 here, 1/7 power? Because that's 7th root. If this had been square root, and this will be just 2, most of the time you're going to get square root problem, as a matter of fact, because it's actually difficult to typeset. And also, there's no reason to make the problem overly complicated by making it into some special radical, which is really hard to see. In printed form, many students cannot distinguish this, especially the printed quality is bad. So most of the time, you're going to end up with square root problem, as a matter of fact. So in that case, you're going to end up with something like this. And then you can go from there. Let's come back to the original problem. I hope you can see the 7th power, or shall I expand the font? Here, 7th root. That goes to the denominator here. Third power, so that goes to the numerator. And entire thing is coming from denominator, so we have negative power. Okay, so far so good. Let's apply the power rule. Add 1 to the power. So add 1, so 4/7. And then divide. So we have to have 7/4. And that's not enough. We have 4 here, so we need 1/a. So if we simplify, this is going to be 7/16, and then 4x plus 5 to the 4/7 power, like that. What did I do in my answer key? Okay, pretty much the same thing, except that I reconverted into this radical expression, 7th root of 4th power, rather than 4/7 power. Personally, I prefer power form. What if I adjust a problem like that into square root so that we get negative 3/2 power? Well, the same for x plus 5. Add 1 to the power, so we get negative 1/2 power, right? And then consequently, this will be reciprocal, 2 over 1, negative of that, and that we have 1/4 in order to undo this. And this entire thing is negative of 2/4, so 1/2. And then we have negative 1/2 power, so it's a square root in denominator. So you can rewrite like this. Let's check. Is this right? Two third power. Yeah, that's right. So we went through some power rule problems associated to this 1 over a. Next, let's work out some exponential problems. But apparently not enough time, so let's stop here and let's resume at next video here. See you soon.